Today we're looking at the free practice math test for the HiSet version FPT-6A, and this is starting with question number 16, which deals with scientific notation. A scientist found that the height of a mountain increased by approximately 5 times 10 to the negative 4 meters each month. If this rate of change continues, by how many meters will the height of the mountain increase in 1 year? Now the obvious choice is to go for this answer right here, because most people are going to see the 12 and the 1 year and they're going to automatically choose that. But you've got to understand how scientific notation works for this question to make sense. So I want to show you a little bit about scientific notation. Scientific notation is a special way of writing numbers, yes, but what we're doing with those numbers is we're taking large numbers such as this one here, and we're writing it in a different way so that the number is actually easier to write on a piece of paper and so that it's easier to do figuring with. If you've ever played around with a calculator before, you know that calculators have their limits, right? If I take 100 and multiply it by 100 and multiply it by 100 again and keep going, what is eventually going to happen with this calculator is it's eventually going to get to the point where it gives me this right here. Okay, so you're eventually going to get to a point where you have a problem, okay, with the calculator, and unless you know how to read this and what it means, you're not going to be able to figure it out. So what we're doing with scientific notation is we're taking a regular number and we're writing it in a different format. Two things you need to know. You need to know that scientific notation is going to have what's called a base number, okay? There's going to be one numeral that is a base number, and that numeral cannot be a 0, okay? So our base number can't be a 0. The zeros are everything else that's not the base number. So I would just want you to look at this number here and don't worry about this side yet. So our base number here is a 7, and then we have all these zeros. Now with the other number that I have here at the bottom, the base number is going to be slightly different, because what we're looking for is we are looking for all of the numbers that appear in a numeral that are not 0. Okay, so we've got the 7 circled, we've got the 4 and the 9 circled. Those things are not zeros. Everything else is a 0. The way scientific notation works is there can only be one base number. So you're going to have a base number, write that down, you're going to have a base, and it's going to be multiplied by 10, always 10, to an exponent of some sort. Okay, so for this first number, our base is 7, because that's the only number that's not a 0. We're going to multiply that by 10 to the however many numbers is left over that are not the number 7, and there are 2 of them, okay, and they both happen to be zeros. So that's how we got 7 times 10 squared, or 10 to the second power, is because the 7 is the base number and there are 2 other numbers that are not a 7. Now let's look at this second one here. It's a little bit more confusing because we have 2 numbers instead of just 1. You still are going to only have one base number, but we have to include any non-zero numerals in our original part of the problem, okay, or part of the solution here. So we have to put the 4 and the 9, but we have to put a decimal in here. This is a decimal. I want you to make sure that you understand that, okay? So these 2 are non-zero numbers. The 4 is still going to be the only base number, and we're also going to put the 9 there. Then we're going to count numbers that are not the 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers in here that are not the number 4, or our base number. That's how we get 4.9 times 10 to the 9th. That is scientific notation. Now let me show you something else. Let me get a new page. Okay, so that one was pretty easy to look at, but let me show you something a little bit different. What if we have a number like like this, okay? This number has a 4, a 6, then a 0, then a 7. What we have to do with this number is still, we're going to make a distinction where the last numeral is that's not a 0. And then we're going to circle all the zeros too, okay? So all of this part where we have numerals that are not zeros, that's going to form our base, okay? The base can only be one number, and then everything else comes after a decimal, 607. So our base would be 4.607, and we would be multiplying that by 10 to the however many numbers we have that are not the base number, okay? That are not that 4, because the 4 is actually our base, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? That's how that works. 4.607 times 10 to the 12th. Now, this is not some weird arbitrary number here. This is actually what happens if you take the number 10 and you multiply it by itself 12 times, which I'm not going to write. I'm going to write 4 times, okay? So if we were to continue writing this and had 12 of those, that's what would happen if we took this number and multiplied it by 10 multiplied by itself 12 times, okay? So keep that in mind, that that's what we're actually doing with this, is we are creating real numbers that actually mean something. And those real numbers, we're writing them in a little bit shorter fashion, okay? Now, I'm going to give you a number that's written in scientific notation, and I'm going to tell you what it would be in real numbers or in standard format, okay? 4 times 10 squared. 10 squared is 10 times 10, which is 100. If you don't know it, do it on your calculator. Then we can take that 100 and multiply it by 4, and 4 times 100 gives us 400, okay? If we subtracted 100 from that 400, we would have 300. And if we wrote 300 back in scientific notation format, we would now have 3 times 10 to the 2, because the 3 would be our base number, the zeros are everything else that's not the base number, okay? So keep that in mind, that you can move from standard format to scientific notation format and back and forth. And that's what you're going to have to be able to do to answer the next question. So, scientific notation, this is what I just showed you. This is at mathisfun.com, and this just shows you how we're moving things with the powers of 10 and how we're moving things back and forth, okay? But if you want more information on this, mathisfun.com, it's all one word, mathisfun.com, okay? It's all one word, and it's something that could be really useful for you to help you understand scientific notation, because it is kind of a difficult concept. So let's go back to our problem. The problem is that this mountain increases by this amount each month, and we need to know how much it's increasing in a year. So I'm going to get another blank page for you, and I'm going to write those numbers out so we can see what happens to them, okay? So the mountain, I think it was 10 to the negative 4. Yeah, 10 to the negative 4. Okay. This is how much the mountain is increasing every year, or I'm sorry, every month. And we want to know how much that means it's increasing by the full year, okay? I can't really do this math because of the way that everything is formatted. It's not formatted in a way that can be done with scientific notation, because this part is in scientific notation, this part is in standard format. So we have to make a decision here. We either have to change this into standard format or this into scientific notation format. It's really difficult to take a 12 and put it in scientific notation because it just doesn't work, okay? So instead of doing that, we're going to have to take the 5 and we're going to have to put it in standard format. Okay, so this is the number 5 right here. All numbers, no matter what they are, have a decimal after them. If you are dealing with whole numbers, if you ever are dealing with a whole number, it always has a decimal after it. We don't write that decimal because we're lazy and there's no point in it unless we have other stuff out there behind it. But in this case, what we're going to do is we're going to write the 5 and we're going to write the decimal because we're going to need it to help us figure something out. Okay? Now what I'm going to do is I have a -4 as an exponent. What I had been doing before is I had positive numbers, and positive numbers would cause my decimal to move this way. Negative numbers, as you can guess, will cause my decimal to move this way. Okay, so what I need to do is I need to move my decimal 4 spaces to the left from here, because that's going to be moving at -4. So I'm going to move it 1, 2, 3, 4 spaces, and I'm going to put the decimal right here. Okay, we're going to pretend like that's a decimal. Now all of these spaces that I have in here can't be empty. They cannot be blank. So I'm going to put, you guessed it, zeros in there. So my new number for this written in standard format is 0.0005 times 12. Now I have both written in standard format. This is in standard format and this is in standard format. Now what I'm going to do is I'm going to go to my calculator because I need to know what this number is. So I'm going to put in 0.0005 times 12. And the answer is 0.006. Okay? Go to your answers. That is none of these answers here. All of these answers are written in scientific notation format. So what we have to do now is we have to change this, which is in standard format, to a scientific notation format. So let me get another blank page for you. So what we're looking at is 0.006. And we want to write it in scientific notation format. What we're going to do is we're going to have to move this decimal until it is behind our base number. Okay? Count as you're moving it. We moved it 1, 2, 3 spaces so that we would be able to put it right here behind our base number. Okay? So our base number becomes a 6. We always use times 10 to the something. And in this case, we moved it 3 spaces. But since we moved it 3 spaces this way, it's going to be to the -3 because we're moving the decimal to the right instead of to the left. So our new answer is going to be 6 times 10 to the -3, which is answer A. Scientific notation, pretty complicated. There's usually only 1 or 2 questions concerning scientific notation on the test. So take that however you want to. Just remember, on the actual HiSet test, you need to get at least 20 out of the 50 correct. Okay? Next problem is a much simpler problem, but I am out of time, so I will pick up on number 17 in the next video.